So welcome to this webinar. It's about SOLIDWORKS plastics and the market, all the packages that we have in SOLIDWORKS plastics, and about the, of course, injection analysis. I'm Alessandro Bellini. I'm your host for today. In the next, let's say, 60 minutes, I would like to present you the package, the capabilities of the software, in order to enhance your experience and maybe to open new ideas, new opportunities for you. Speaking about the agenda, we will see about the injection molding process, just to summarize it. Then we will talk about, of course, SOLIDWORKS plastics, and we will see a demonstration, a brief demonstration about the three package, the main three package of plastics, so plastic standard, professional, and premium. In the end, if I have enough time, I would like to show you experimental validation done by professor and people from UMass University in Massachusetts. Let's talk about the injection molding process. Basically, we have four main portion in this process. The first of all is filling the cavity. So you can imagine a void in a mold filled by the plastics. Then there is a packing phase. It's to avoid shrinkage, and it's called pack because the pressure is packed inside of the mold, inside the plastic part. And then there is starting the cooling system to cool down the mold and the plastic part itself. And after that, and this is part also of the software, we will see the opening of the mold, the ejection of the part, and also the warpage of the part, of the plastic part, due to the thermal stress, the difference in temperatures between the plastic part and the outside temperature. Let's see also the machinery for in plastic injection. Basically, we can see this kind of four parts. The injection system in the back, the mold itself, that is the cavity that is contained the cavity to fill the plastic, the clamping system to retain the mold before opening, and the control system, of course, the electronic part for all the process. In terms of the process, we can see that we are starting from the plastic pellet hopper, that is basically a funnel with this kind of small plastic parts. These plastic parts are heated here and then injected inside the mold by a screw into mold cavity. And the mold clamping force is retaining the mold, is closing the mold. After this process, there is a coolant circulation system that is removing the heat from the mold, and then the mold is opened. Let's talk now about the challenges of today's companies. Of course, more these days, it's important to developing new products, and for the new products, the important things are the high quality, of course, the innovation of the product, and of course, from the production point of view, it has to be faster and cheaper. This kind of issues of the company can be improved in the processes. So to have a shorter time to market, to decrease the cost, and to reduce the errors. And the virtual simulation, in this sense, it's very important. Here I would like to share with you some results done with the SOLIDWORKS customers all over the world with a survey, and of course in the plastic market, let's say. And in this case, you can see that most of the respondents, 75% of the respondents, have in the past done some rework of their molds. at least 2 times before they can produce it, the good parts from it. And this should be, let's say, very critical for the companies, because maybe you know already just one or two modification of the mold, it's very costly. Okay. So why I'm talking about SOLIDWORKS plastics for the companies? Because it's a design tool in this case. So what I mean by a design tool, if you imagine which are the processes, the phases inside your company, maybe you can recall that you have a concept phase, and after that, if you are using simulation, let's say in this case plastics, with let's say the idea of optimizing the product, optimizing the plastic part, you can resolve immediately this kind of issues without having any prototype at all, because you are doing virtual simulation. And you can build up also design scenarios, and you can also optimize, for example, the thicknesses or the material and so on. So having that said, the benefits are almost intuitive. For example, you can have lower cost due to the reduction of prototypes. You are not doing prototypes, or at least just the final prototype. You have more time to find the optimal solution, because you are doing it in the same environment. You have SOLIDWORKS, you are designing plastics part inside SOLIDWORKS, and immediately you can find out which is the best solution from the production point of view. And of course, quicker design changes are leading to a shortened time to market, because you are very quickly to go to the market. And this can lead also to innovation. So let's talk about the packages. The first is plastics standard. The plastic standard package is for part designer, so it's not meant for the mold maker. It's for the let's say, let me use the word for the newbies. Let's say for the person that are going to use SOLIDWORKS for designing a plastic part, but they want something more and quickly. They want to know some basic question, to know if the part is filling, if it's filling completely, if there are some weld lines or air traps, just to prevent some problems. Imagine if you don't have this information. Basically, you are relying on the mold itself, on the mold maker itself. So, and most of the time it's outside of the company. And then you have to redone some work because of the mold maker have told you to modify something, maybe the thickness or the position of a rib or something else. So you can simulate immediately, very quickly, and I will show you how to fill the part, which is the time, and some problems that can arise. Plastics Professional. Plastics Professional is the second level, is the advanced level from Plastic Standard, and it's both for mold designer and mold makers, but also from production point of view. It's very important for the company that are producing plastics parts. Why? Because in this case, you have the ability also to check for the packing phase, so you can optimize also the total time of the injection, not only the filling, but also the packing phase. That most of the time it's longer than the filling. So also you can have the optimization strategy for single and multi-cavity layouts. You have the ability to enhance the balancing of the mold with the automatic balancing system. You can determine the injection pressure, because also this is important in production to understand which is the best machine to use in this case. And of course there are some additional features like overmolding, gas assist, valve gates, and so on. Let's talk now about Plastics Premium. Plastics Premium is the most advanced package in our family for plastics, and of course again is for mold designer, for mold makers, and of course for the analysts. In here you can analyze, of course, all the processes related to injection plastics. For example, also the cooling system. So how it's performing the cooling system, the temperature, the final temperature, and also the warpage, the so-called warpage of the part. So after the opening of the mold, you can find out which are the deformation, the permanent deformation in the part. And of course you can optimize the cooling system. Okay, so let's go on. First of all, I would like you to show some of the capabilities of plastic standard. I mean, from feeling point of view, configuration change inside SOLIDWORKS, checking time, temperature, and so on. Okay, let's switch to SOLIDWORKS. Okay, so here I have just a plastic part. It's a smoke alarm casing. So basically it's plastics with some thicknesses, with some ribs and so on. Okay, here the first step is to start, of course, with a configuration. I will later change it. So it's a configuration of SOLIDWORKS because it's embedded in the same environment, as you can see. And I will start to create an analysis where I can start just to create a shell mesh. A shell mesh is about discovering, let's say, creating the external representation for the analysis. Okay, so here you can see you have steps like in a wizard. It's very simple. Now I have to choose the size and to mesh it. I can of course change the gradation from smooth to sharp. I can show you, it's very fast. So in some seconds I can see a preview of the mesh, and if I'm satisfied I can go on with the analysis. Okay, let's say this is good. Okay, here I have a summary, so I can check. Of course I have the mesh editing capability if I want. Okay, so now the fact is that I have to select the polymer. So it's very simple. Double click here and you will see a very simple database from to choose from. And I would like also to show you, for example, in the PP category, just some hundreds of material, or for example in ABS another 500 materials. And for all of these materials, let's say this generic polypropylene, you have the curve, so the exacting the matching, let's say, behavior of the material. Of course, other material properties, and of course the parameters. For example, here you can note the maximum melt temperature or the mold temperature. This is decided, this is suggested from the material producer. Okay, so of course you can select your own material here if it's in the database. You can add yourself your material if you want, and also from this year you can have access to Materiality web portal to have to download new materials as well, and it's updated every month.